Okay, welcome to another screencast about the photosynthesis lab and the colorimeter and the supplemental stuff, etc. here. So this is the slide from the other supplemental thing, so this will be supplemental 2, talking about what the heck is going on with the colorimeter in the lab. So let me just start here. What you're going to have, right, is a cuvette. Sorry. You've got your cuvette, and inside that cuvette is going to be, I'm having some troubles here, inside that cuvette is chlorophyll, right? So this is cuvette 1, and we're going to shine 635 at it when it's in the colorimeter. Now since chlorophyll is green, it's going to absorb most of that red wavelength of light. So some of that red wavelength will come through, but not all of it. So let's say that this is whatever, 13% transmittance, right? And the absorbance then here is going to be pretty high. So these values are not percentages, there's some other values, so just make it up, like 3.21 is about what that's going to read. So the colorimeter is going to be reading that. So you're going to calibrate this colorimeter. So to calibrate it, calibrate means to zero it or to tear it. If this is the balance, right, you're going to tear this. So what's going to happen is you put this cuvette number 1 into the machine, and it's going to read this. So what you're going to do is you're going to calibrate it and say that whatever you're reading right now, however much 635 is coming through their transmittance, you're going to make that equal to 100% transmittance. So this is what you're doing when you do that second calibration point. The first calibration point is saying you're going to setting this absorbance. You're going to make that absorbance equal to 0. Right? So 0 absorbance, and this is the first calibration point. Okay? So during the calibration, this is what you're doing. So now, after you calibrate, you're going to have this cuvette 1, and in there is going to be chlorophyll. Right? And you can compare this to, now say, cuvette 3, or in 2 and 4. Right? So in these cuvettes, you're going to have chlorophyll. This green doesn't make a difference. I just tapped the wrong color green there. So you're going to have chlorophyll there, and you're going to have DPIP. Right? So now, when you take this setup here, right, and you put this behind a light source, right, which is behind a heat sink. This is a light. Right? Light's going to be shining through this, right, chlorophyll, and exciting electrons, doing whatever. That same light's also going to be shining on here, exciting electrons, and as it does, as the chlorophyll absorbs those photons of light, electrons are going to get excited, and this DPIP is going to be reduced. Right? So at time 0, in the cuvette, pardon me. So you're going to have DPIP, which is blue in color, right? At 3 minutes later, after you turn that light on, this DPIP is going to be blue. Yes, but it should be less blue. Should be less blue. And then at time 6, when I put this cuvette back in the machine, it's going to be detecting DPIP, and this should be less blue, or even more less blue, right? And at time 9, the DPIP should be less blue, going ultimately to colorless at time, who knows, whatever, all right? We don't know how long it's going to take. So what you're doing is you're measuring with the colorimeter how fast that blue is going away, because, let's go back up to here just a second, this DPIP right here, well, that DPIP that's in that cuvette, when you put it into the colorimeter, let me draw that a second. So here is this. That DPIP that's in there, and there's chlorophyll in there. And I'm shining 635 at it, right? I'm shining 635 at this DPIP as well, right? Will this chlorophyll be absorbing this 635? Yes, but you told the colorimeter when you calibrate it to ignore this. So you're setting this equal to 100% transmittance and zero absorbance. So you're ignoring this. So any changes in the colorimeter, right, any change in the reading is due to DPIP changes, right? Because this blue absorbs red, right, and transmits red. No, absorbs red. Yes. Now, as the experiment down here, as time goes on, right, this is blue, less blue, less blue, less blue. Right? So this DPIP is going away. So what would you predict should be happening to the absorbance readings and the transmittance readings of this cuvette over time? That is the question, right? What would you predict is happening to the absorbance readings and the transmittance reading of these cuvettes over time? So here's time, right? So what would you predict is happening to the absorbance readings, and what would you predict happens to the transmittance readings? And you can just either do this on a double Y, or you can have two of these on there. So draw a line on there, like predict, make a prediction. What would you expect happens to cuvette number 1 over time? Right? The absorbance and the transmittance readings to cuvette 1, or not, sorry, not 1. What's going to happen to 2? What's going to happen to 3? What's going to happen to 4? Right? So you can do, just use colors here and try this again, right? So then let's say for the dark, right, absorbance and transmittance, so the purple color is for the dark. So you'd have purple lines on that graph. Right? The black lines, we'll say, is for cuvette number 3, and whatever the orange ones here, what would you predict is happening to the absorbance and the transmittance for cuvette 4, right? So what happens, what would you predict would happen with those? Ink color purple. What would you predict is happening with these guys? That is really annoying. I apologize. And then what would you predict is happening with these? Right? Then, of course, the question is, again, why do you have cuvette 1? And then what is going on over here with cuvette 5? What is cuvette 5 telling you? Why should you have that? Why do you need that? Right? So hopefully that is a little more helpful or a little more explanatory, and be looking for you to come to class maybe or Broom Block with this graph over here completed, and that will let me know if you understand exactly what happens here. Okay, hope that was helpful.